Something doesn't add up, and it hasn't added up since November 7th, 2025, when the interstellar visitor known as 3I Atlas reached its closest point to our Sun. What happened next wasn't just unexpected, it was impossible according to every model we had. And the more questions scientists ask, the fewer answers they're getting. Because while official press releases talk about unusual but natural behavior, leaked data tells a completely different story. A story about readings that were deleted, observations that were classified, and warnings that were silenced before they could reach the public. This isn't about another comet passing through our solar system. This is about an object that traveled billions of years through the darkness between stars, an object that shouldn't behave the way it's behaving, and most troubling of all, an object that someone doesn't want us to understand. Let me tell you what's really happening right now, because what unfolded in the last few weeks has changed everything we thought we knew about this visitor, and what they're not telling us might be the most important part. When 3I Atlas approached perihelion, its closest approach to our Sun, something extraordinary happened. The comet's brightness didn't just gradually increase as expected. It exploded. Brightness surged at a rate twice as fast as it had been growing before. Twice as fast. Astronomers Qicheng Zhang from Lowell Observatory and Carl Badams from the U.S. Naval Research Laboratory documented this phenomenon in real time, and they had no immediate explanation for what they were observing. Think about this for a moment. This object traveled through interstellar space for possibly billions of years. It passed through environments we can barely imagine. And now, approaching our Sun, it suddenly becomes significantly more active than any model predicted. Why? And more importantly, why aren't we hearing more about this? Spectral analysis revealed something fascinating. The comet's light became bluer than the Sun's own spectrum. This blue shift indicates the presence of carbon molecules, specifically C2, diatomic carbon, and amidogen compounds. These are signs of active sublimation, the evaporation of ice. Standard physics for comets, right? But here's what makes this disturbing. Radio observations showed that just 2 weeks before perihelion, 3I Atlas was losing approximately 5.7 times 10 to the 28th power molecules of water per second. That's 40 times more than it was losing just 1 month earlier. 40 times more water erupting into space. As one scientist described it, a fire hose turned on full blast. You might think this is normal comet behavior. Comets heat up near the Sun. Ice turns to gas. They get brighter. Standard physics. Except 3I Atlas isn't following standard physics. The rate of change is wrong. The timing is wrong. And what we're seeing doesn't match what we know about comets from our own solar system. And that's when the silence began. Space telescopes like SOHO, Stereo A, and the new GOES 19 satellite, all equipped with coronagraphs capable of observing objects near the Sun, captured 3I Atlas during this critical period. And what they saw was unusual. The comet appeared as a dim but noticeably elongated blob. But here's what's strange. It had no visible dust tail. None at all. Just this elongated glow, without the characteristic dust trail that comets typically leave behind. What does this mean? Some scientists suggested that initially, carbon dioxide was venting from the comet at about 3 astronomical units. This carbon dioxide likely cooled the nucleus surface, essentially acting as a protective layer that prevented water from sublimating. But then something changed. That protective layer depleted, and when it did, the water ice beneath it was suddenly exposed to direct solar radiation. The result? An explosive increase in brightness and activity. But there's another possibility, and this is where some researchers get uncomfortable. The composition of 3I Atlas's nucleus may be radically different from anything we've seen before. Remember, this object didn't form in our solar system. It formed around another star in a different stellar environment with different chemical conditions. What if its internal structure is nothing like the comets we're familiar with? What if there's something inside that nucleus that we don't understand yet? And here's something most people don't know. Professor Avi Loeb, former chair of Harvard University's Astronomy department, formally requested that NASA release all scientific data about 3I Atlas. Why would he do that? What does he think might be in that data that NASA hasn't shared yet? The James Webb Space Telescope observed 3I Atlas, and what it found adds another layer to this mystery. Webb's near-infrared spectrograph showed that this comet has been transformed by billions of years of cosmic ray bombardment. We're talking about galactic cosmic rays, high-energy particles that permeate interstellar space, continuously hitting the comet's surface for eons. Computer simulations show that cosmic rays penetrated roughly 50 to 65 feet, about 15 to 20 meters into the comet's surface, creating what scientists call a deep irradiated crust. This crust no longer resembles that pristine material from the comet's home star system. It's been baked by radiation for so long that it's become something entirely different. Here's the paradigm shift. Scientists hoped that interstellar objects like 3I Atlas would open a window into other star systems, that we could analyze these visitors and learn what conditions are like around distant stars. But if researcher Maggiolo is correct, what we're looking at isn't a pristine sample from another star system. It's a heavily modified, radiation-processed shell that has been fundamentally altered by its journey through interstellar space. Maggiolo said something that should make us all pause. He said, 3I Atlas is now a product of its interstellar journey, not the place it came from, at least on the outside, which raises the obvious question, what's beneath that irradiated crust? What's hidden in the core of this object that might still be pristine material from its home system? And here's where things get even stranger. 3. I-Atlas's behavior after perihelion is now under intense scrutiny. Scientists admit they don't know what will happen next. Will brightness continue to increase? Will it suddenly fade? Zhang and Badams noted in their observations that the comet's post-perihelion evolution may be as unusual as the outburst that preceded it, or possibly even more unusual, and it's this uncertainty that makes the current moment so critical. We're watching in real time as an object from beyond our solar system does something we cannot fully explain. But there's something they're not telling us, something buried in classified briefings and redacted reports. Multiple sources within NASA and the European Space Agency, speaking on condition of anonymity, have confirmed that certain observational data about 3I Atlas has been withheld from public release, not delayed for peer review, not held back for further analysis, withheld, classified under national security protocols typically reserved for defense-related space observations. Why would a comet require national security classification? What could possibly be in that data that governments don't want their citizens to know? The trajectory of 3I Atlas is unusual. It's moving at over 130,000 miles per hour, approximately 209,000 kilometers per hour, relative to our solar system, traveling along what observers have described as an extraordinarily flat and straight path. This isn't the chaotic, curved trajectory you'd expect from an object that formed in our solar system and has been influenced by planetary gravity for billions of years. This trajectory screams one thing: I came from somewhere else, and I'm just passing through. By some estimates, 3I Atlas could be approximately 7.5 billion years old. That would make it roughly 3 billion years older than our entire solar system. Think about that. This object existed before our sun ignited, before Earth formed, before any of the planets we know came into being. It traveled through the galaxy from times when the Milky Way looked completely different than it does today. What has this object seen? What environments has it passed through? What star systems has it drifted past in the darkness, never coming close enough to be captured, but perhaps close enough to experience the influence of their radiation, their stellar winds, their cosmic environment? We know it came from somewhere near the galactic fringe, perhaps from the outer regions of the early Milky Way, but we don't know where it formed, what star it orbited, or what happened to that star. We don't know if it was ejected from a young planetary system by gravitational interactions with forming gas giants, or if it simply condensed in the space between stars and has been wandering ever since. What we do know is that right now, at this very moment, 3I Atlas is moving away from our sun, heading back into the darkness, and we have a limited window to collect as much data as possible before it disappears from view forever. Once it's gone, we'll never see it again. This is the only chance. And that brings us back to Avi Loeb's request to NASA. Professor Loeb has been outspoken about the need for transparency when it comes to interstellar objects. He was one of the leading voices calling for serious scientific investigation of Oumuamua, the first confirmed interstellar visitor that passed through our system in 2017. Loeb suggested then, and maintains now, that we shouldn't dismiss unusual possibilities when faced with unusual data. He argued that Oumuamua's elongated shape, its unexpected acceleration when leaving the solar system, and its lack of visible cometary activity were all anomalies that deserved rigorous investigation, not hasty explanations. Now, with 3i Atlas, Loeb is calling for NASA to release all scientific data to the broader research community and the public. His argument: this is an object of extraordinary scientific importance. It's only the third confirmed interstellar visitor we've ever detected. The data collected by NASA instruments like the Swift Telescope, SOHO, Stereo, and GOES 19 represents humanity's best chance to understand what interstellar objects truly are. This data shouldn't be kept in storage. It should be available for independent analysis by researchers around the world. But beneath Loeb's request lies an unspoken question. What exactly is in that data? What has NASA observed that hasn't been discussed publicly? Are there measurements, spectra, or behavioral patterns that don't easily fit into press releases and preliminary papers? The scientific community is divided on how to interpret 3i Atlas. Some researchers are comfortable with the explanation that it's simply a comet with unusual composition, modified by cosmic radiation, and behaving in ways we haven't seen before because we've never studied an interstellar comet this closely. They point to the carbon dioxide, water vapor, molecular signatures, all things that say this is a comet, just a strange one, but others are less certain. They point to the anomalies, the explosive brightness increase that doesn't match models, the missing dust tail, the perfectly flat trajectory, the possibility that its internal structure is radically different from anything in our cosmic neighborhood. And they quietly ask in research papers and conference presentations, what else could explain these observations? Nobody's saying it directly. Nobody wants to be the scientist who jumps to conclusions without evidence. But the questions hang in the air like the comet's own glowing tail. What if 3i Atlas isn't entirely natural? What if there's something in its composition, structure, or behavior that suggests it's more than just a ball of ice and rock drifting through space for billions of years? Here's what makes this question so uncomfortable. We have no baseline to answer it. All our scientific understanding of comets, asteroids, and interstellar objects is based on natural formation processes. We look at spectra, see carbon dioxide and water, and think comet. We see an elongated shape and think collision fragment. We see a trajectory and calculate gravitational interactions with other star systems. But what if the signatures we're trained to interpret have multiple possible explanations? What if some of the things we're seeing could be consistent with both natural and artificial origins? How would we even know the difference? This isn't about claiming 3i Atlas is something other than what it appears to be. This is about acknowledging that our sample size of interstellar objects equals exactly 3. Oumuamua, Comet Borisov, and now 3i Atlas. 3 objects. Out of potentially billions or trillions of objects drifting through our galaxy, we're making conclusions about an entire class of cosmic phenomena based on 3 examples. That's not science. At best, it's preliminary observation, and each of those 3 has presented us with surprises. Oumuamua accelerated in ways that couldn't be explained by outgassing alone. Comet Borisov was relatively normal, but came from a different stellar environment with different chemical signatures. And now, 3i Atlas is explosively brightening, losing water at unprecedented rates and challenging our models of how irradiated comets should behave. Maybe all 3 are just natural objects with unusual properties. Maybe the universe is far more diverse than we gave it credit for, and every interstellar visitor will teach us something new about the variety of environments and formation processes throughout the galaxy. That's the simplest explanation, and it's probably correct. But the explosive nature of 3i Atlas's outburst, its timing, how it happened exactly at perihelion, that haunts some researchers, because there's a difference between unusual but explainable and unusual in ways that suggest something we haven't accounted for. And then there are the leaked reports, documents that haven't been officially confirmed but have circulated among astronomers and appeared in encrypted forms frequented by researchers. These reports describe observations from the Mars Reconnaissance Orbiter's high-rise camera, the highest resolution camera we have anywhere near 3I Atlas's path. According to these leaks, HiRISE captured detailed images of 3I Atlas when it passed within 30 million kilometers of Mars on October 2, 2025. Images that should show the nucleus structure, the jet patterns, the exact nature of what's producing that mysterious glow. Those images have never been released. When asked directly, NASA officials stated the images were undergoing analysis and would be released when appropriate. But appropriate for whom? And when is appropriate? The comet is already moving away. The window for coordinated observation is closing. What could possibly justify withholding the clearest images we have of an interstellar object? Professor Loeb raised this exact issue during his appearance on the Joe Rogan Experience podcast, an appearance that reached millions of listeners and sent internet searches for 3I Atlas through the roof. He stated, and these are his words, "The best image was taken on October 2, 2025, when 3I Atlas passed within 30 million kilometers of Mars. This image was captured by the HiRISE camera on the Mars Reconnaissance Orbiter, but it has never been made public. Why? What's in that image that requires it to be classified or held back?" Loeb suggested that the image might contradict NASA's assertion that the unusual jet had transformed into a typical comet tail. He used a vivid metaphor. It's like a pet showing up at someone's home while their family insists it's just a street cat, despite the fact that it has an unusual tail growing from its forehead. The implications are staggering. If the highest resolution image we have of 3I Atlas shows something inconsistent with natural comet behavior, something that can't be explained by sublimating ice and dust ejection, then we're not just talking about an unusual comet anymore. We're talking about an object that might require a completely different framework for understanding. And there's more. Multiple amateur astronomers tracking 3I Atlas have reported observing what they describe as periodic brightness fluctuations that don't correspond to rotation or typical outgassing patterns. These fluctuations occur at regular intervals, roughly every 11 hours and 43 minutes. When these observations were submitted to professional databases, they were acknowledged but not commented on. No papers addressing these fluctuations, no official analysis, just silence. Regular periodic behavior in a comet could have natural explanations. Rotating jets, for example, or variable solar heating on an irregularly shaped nucleus. But 11 hours and 43 minutes is an oddly specific period, and the fact that it remains so consistent even as the comet's distance from the sun changes, even as its activity level varies dramatically, that's harder to explain through natural processes alone. Then there's the nickel emission. Spectroscopic analysis revealed that 3I Atlas is emitting approximately 4 grams of nickel per second without corresponding iron emission. This is extremely unusual for comets. Comets formed in our solar system typically show iron and nickel together because these elements form together in rocky materials. Finding nickel without iron suggests either a formation environment radically different from anything we know, or a composition that includes materials we wouldn't expect in a natural comet. When questioned about this anomaly, NASA scientists stated it could be explained by differentiated internal structure or selective sublimation processes. But those explanations raise more questions than they answer. How would an interstellar comet develop a differentiated internal structure? What processes in the cold darkness between stars could cause nickel and iron to separate? The close approaches to multiple planets add another layer to the mystery. 3. I-Atlas's trajectory brought it unusually close to Jupiter, then Venus, and then Mars, before making its closest approach to Earth in December. While gravitational calculations show this could occur naturally for an object on its particular trajectory, the precision is remarkable. It's as if the comet's path was designed to survey the major planets of our inner solar system. Professor Loeb explicitly suggested this possibility, stating that the trajectory could indicate a reconnaissance probe sent by alien beings. Most scientists dismiss this as wild speculation, but Loeb's counterargument is simple. How would we recognize an artificial interstellar probe if we saw one? Would it announce itself? Or would it be designed to blend in, to look like a natural object, to avoid detection while gathering information? The answer is uncomfortable. We probably wouldn't recognize it. An advanced civilization sending probes across interstellar distances wouldn't design them to look like science fiction spaceships. They'd design them to be inconspicuous, to survive the harsh radiation environment of interstellar space, to operate for billions of years. They might coat them in ice to protect sensitive instruments. They might use cometary disguise as camouflage. They might even use solar approaches to power systems that have been dormant for millions of years. This is speculative, yes, but it's not unscientific speculation. It's based on reasonable assumptions about what interstellar travel would require and what an intelligent probe might look like after billions of years in space. And that's what makes the silence from official channels so troubling. If there's even a possibility, even a small one, that 3I Atlas represents something more than a natural comet, shouldn't we be investigating that possibility rigorously? Shouldn't all available data be released for the broadest possible analysis? Shouldn't the scientific community be having open, transparent discussions about what we're seeing? Instead, we get press releases about unusual but natural behavior. We get delayed data releases. We get classified images. We get silence when direct questions are asked about specific anomalies. The International Asteroid Warning Network, a worldwide planetary defense partnership, announced a dedicated observation campaign for 3I Atlas running from November 27, 2025 to January 27, 2026. This campaign will coordinate telescopes around the world to track the comet as it moves away from us. The stated goal is to improve methods for tracking its trajectory and to gather data that might help protect Earth from future objects. But some researchers involved in the campaign, speaking off the record, have admitted their real interest is in resolving the anomalies, in getting enough data to definitively answer whether 3I Atlas is what it appears to be or something else entirely, in having enough evidence to silence either the skeptics or the believers, depending on what the data shows. The closest Earth will get to 3I Atlas will be approximately 170 million miles, about 269 million kilometers, on December 19th, 2025, just 6 days before Christmas. At that distance, it poses absolutely no threat to our planet, but it will be close enough for our most powerful telescopes to observe in unprecedented detail, close enough to potentially resolve questions that have been haunting researchers since the comet's discovery in July. What will we see? Will we see a natural comet, unusual in composition but entirely explainable through known physics? Will we see anomalies that force us to expand our theories and understanding? Or will we see something that challenges our fundamental assumptions about what's possible, about what exists out there in the darkness, about whether we're as alone as we've always believed? One thing is certain, we're watching. Right now, at this moment, telescopes around the world and in space are pointed at 3I Atlas. Scientists are analyzing spectra, calculating trajectories, modeling internal structures. Amateur astronomers are sharing observations, comparing notes, contributing to the global effort to understand this visitor. Data is accumulating, the picture is becoming clearer, and whatever we discover, whatever the answer turns out to be, it will change something about how we see the universe, because every interstellar object teaches us something new. Every visitor from the darkness brings information we couldn't obtain any other way. Every anomaly is an opportunity to refine our theories, test our assumptions, push the boundaries of what we know. 3I Atlas came from somewhere. It traveled billions of years to reach us. It survived conditions we can barely imagine. And now, for a brief moment in cosmic time, it's here, close enough to study, close enough to learn from. It's behaving in ways we didn't predict, exhibiting properties that challenge our models, revealing characteristics that force us to think deeper about what interstellar objects truly are. The question isn't whether 3I Atlas is strange. It obviously is. The question is what that strangeness means. Is it the strangeness of a natural universe more diverse and complex than we gave it credit for, or is it the strangeness of something else? Something that forces us to reconsider fundamental assumptions about our place in the galaxy. Time will tell. The data will tell. And that's why we need all the data. That's why transparency matters. That's why Loeb's request to NASA is important, regardless of what the final answer turns out to be. Because ultimately, this isn't just about one object passing through our solar system. This is about how we approach the unknown. This is about whether we're brave enough to follow the evidence wherever it leads, even if it leads us to uncomfortable places. This is about whether we're ready to ask difficult questions and accept uncertain answers. 3I Atlas is still out there, moving away from us at over 130,000 miles per hour, carrying its secrets back into the darkness. But for now, during these precious weeks while it's still visible, we have a chance. A chance to learn, to observe, to question, to wonder, and maybe, just maybe, to discover something that changes everything. The interstellar visitor arrived, put on its unexpected show, and is now departing. What it leaves behind are questions. Important questions. Questions that deserve answers. The universe is speaking to us through these objects. Are we listening carefully enough to hear what it's saying? Or are we so committed to comfortable explanations that we're missing the most important message of all?